All people, thanks for the participation. Do you hear me, please? Because Professor Musolino have a problem with the phone. Then I would like to ask you if we can start with the third presentation. And I don't know, is the presentation by Antonio Barbagallo, Vincenzo Torrisi, Stefano Ricci, Ellen Guid, and Matteo Ignacco. Can you give the presentation? I don't know. Antonio, okay, yes. Thanks.
Okay, good morning.
If it's possible, you can start and then
yes,
we follow with the other presentation. And as the last presentation, we give the presentation of Professor Musolino. If I have a problem, I give it.
Okay.
Okay. Thanks, Antonio.
You see the presentation?
Perfect. Yeah. Okay. We see good your screen.
Okay. Good morning. With this presentation, I have got the pleasure to present this work titled Assessing Ship Emissions at an Estimation Approach Applied to the Port of Catania, which is a joint work between the University of Catania with me, Professor Matteo Ignacco and Professor Vincenzo Torrisi, Sapienza University of Roma with Professor Stefano Ricci, and the University of Ljubljana with Professor Ellen Guid. This is the outline of the presentation. We will start with a focus on the context of the environmental impacts of ships during the port operation. Subsequently, we will analyze the case study of the port of Catania, describing the geographical and operational characteristics and the import of ro-ro traffic in this area. Subsequently, the methodological approach will be detailed through the data collection process and the emission estimation model and the use of regression analysis to refine the calculation. Finally, the study concluded with a discussion of on the possible implication and the direction for future research aimed to improving the accuracy of the estimated and supporting more sustainable maritime policies. Maritime transport play a key role on global trade and economic development, enable the movement of goods and passengers over long distance. However, it is also a significant source of air pollution, contributing to the pollution emission. These emissions have a serious environmental implication, especially in the coastal and in port areas, where shipping activities are concentrated. Among the various operational phases of ship, hoteling is one of the main causes of the local pollution. Emission in ports are growing challenge of the environmental sustainability, which has integrated the environmental impact of the port into European and international policies. In fact, reducing emission is closely linked of the sustainable development goals of the 2030 agenda, including Goal 11, Goal 9, and Goal 30. Measures such as dock electrification, use of the clean fuel, and the logistic optimization and emission monitoring are now key tools for the greening of ports. In this context, effective methods for assessing and establish ships generated emission are essential for the definition of effective operational strategies and environmental policies. In these regards, we proposed a data-efficient approach based on work to estimate the emission generated by ro-ro vessels during the operation, the hoteling phase in the port of Catania. Within this section, we introduce the analyze case study of the Port of Catania, a strategic infrastructure for the maritime traffic in the Mediterranean basin, located in the east of coast of Sicily. The strategic geographical position of the Port of Catania extends its influence over the entire regional territory. As an important hub, its support and a land area represent Sicilian provinces. The Port of Catania is located close to the historical city center, a characteristics that has influenced both the urban development and local socio-economic dynamics. This proximity it's raised concern about the pollution emission and their impact of the urban air quality. The main source of emission in ports include dock ships, cargo handling activities, and associated vehicular traffic. The study focused on the docking phase, which has the great influence of the emission impacts in this area. Regarding the traffic, the Port of Catania is characterized by the movement of many ro-ro ships. In 2023, a total volume of approximately 7 million tons. 7 million tons. The methodological approach is characterized by three phases: data collection, model estimation, emission estimation, and estimation using regression curves. Structural characteristic of and operational parameters of ship is retrieved from the automatic information system data, quindi ACE data, collected through the vessel find platform. For this work, the gross tonnage, which represents the measure of the ship internal volume and can influence the energy consumption and emission during the hauling phase. We also collected the time of hauling, which refers to exclusively to the duration of the berthing phase, during which the ships remain at the berth with the auxiliary engine running to the ensure onboarding service. This work, the hauling phase, is considered occurs when the ship is stationary in port, using auxiliary engines to generate electricity powering onboard services. The estimation of the emission for auxiliary engines during the hauling phase is calculated with an equation that depends from time of hauling, auxiliary engine nominal power, auxiliary engine load factor, and emission factors. Turn the power of the auxiliary engines is calculated starting for the power of the main engines, which depends on the gross tonnage. The accuracy of the port emission estimated is highly depend on the reliability of the emission factor available in the literature. Which have significant uncertainties related to the vessel type and the operational condition. Finally, emission estimates based on the regression curves is used to establish the empirical relationship between the technical parameters of the ship and generated emissions. The emission estimation was conducted on ro-ro vessel operating in the Port of Catania, focusing on the hauling phase, during which the auxiliary engine remain switched on to produce electricity. First, the automatic information system data were collected from the ship that called at the port of Catania, and among those only Ro-Ro cargo ships were selected. We calculated the power of the installed main engine and multiplying it for the estimation average auxiliary and main engine radio. We obtained the auxiliary engine power. Once auxiliary engine nominal power for each ships was obtained, the estimation of emission for hotling of Ro-Ro ships were carried out using the equation and considering auxiliary engine load factor for 0.4 corresponding to the stay-in port. And in applying emission factor from the literature. From this graph, it can be seen that estimation increasing as the hour spent in berthing increase, but it is not the case of the gross tonnage. In fact, in the estimation of total emission, the weight of hours spent in berth is greater than of the gross tonnage. Therefore, the option of performing a simple regression based only in time of hotling is also considered. These regression curves are implemented by using the data analysis tool, and the coefficients are reported in this table. Results are influenced by the limited number of the measurements included in the methodological application. Nevertheless, we can observe that the second degree polynomial curves has cycling higher reliability. Is one compared the total emission obtained, which those remaining for the regression curves using equation. One can see that of the Eurocargo ships, the values obtained is, with the regression curve are very similar to those calculated. For the Equitalia ship, on the other ends, lower values are found. The analysis also showed that hotling time has graded the impact of the estimation that other parameters, such as gross tonnage. These results can be attributed to the relative homogeneous composition of the Ro-Ro fleet's operation in the port of Catania.
Sorry, could you hear me? Could you hear me?
Yes.
Okay, please continue.
Okay. This homogeneity limits predictive
couple of minutes, please. A couple of minutes.
Yes. The conclusion. This study proposed the implementation of the data efficiency methodology proposed in literature for estimation emission from Ro-Ro vessel in the port of Catania, focusing on the phase in which ship remain docked in the port with their auxiliary engines running to ensure the operation of onboard systems. Based on the analysis of the ICE data and the emission estimation model, it was possible to quantify the environmental impact of the ship. This methodology is applied when no emission data from sensors are available, or no other type of data it's available. Okay, find of the study is that time of hotling has a more significant impact on the total emission than gross tonnage. This method make it easy possible an initial assessment of the environmental impacts of the maritime transport without having to carry out complex calculation. However, emission factor must be taken into account as these present significant uncertainties. This type of analysis can provide concrete support to port authorities and local authorities in defining strategy to reduce the environmental impact in line with European sustainable and decarbonization objective. Future research could be expanded into several types of the ship and longer observation periods, as well as an integration of more detailed data on engine operation characteristics. In addition, the implementation of more advanced predictive model could further improve the accuracy of estimation in contributing to a more sustainable management of maritime transport system. This work was carried out as part of the research project, the Master, coordinated by Professor Stefano Ricci, with the contribution of the University of Catania and the University of Ljubljana. We would like to thank all the partners for research. Thanks you for your attention.
Yes, thanks, Antonio. Thanks for the presentation, for the cooperation between different universities. I want to give the words to Professor Musolino if the technical problem has been resolved.
Thank you, Professor Rocco,
Okay.
for supporting me.
It's good. It's good. Okay, but it's good. Now we are very good.
I hope so.
Just if there is question and demand to Antonio Barbagallo.
Okay. No, just a question from me.
Okay.
I'm surely missed the part of your presentation, but what is the hotel the hoteling time for you? Is the time at berth or time at port?
It's time at berth.
At berth.
Because when the ship is in a port, there are three phases: maneuvering, berthing, and go in the sea.
And what about the data sources? From where you obtained the data? From
we obtained the data from the vessel finder site. It's open in an open source.
It's open source.
Yes.
Okay. Thank you. So I think we can. There were two presentations from me at the beginning, but we can skip at the end. I think we can continue with Elena Cucuzza is it present? Yes, I think so. Elena, we cannot hear you. Elena.
I'm sorry. Yes, I'm here.
Okay, Elena. You're a little bit late, 15 minutes for your presentation, please.
Yes, okay, thank you. Just a moment. Elena, are you ready for your presentation? No, may I have please 5 minutes?
Okay, so I start.
Okay, thank you. Sorry.
Okay. I'll try to select. Okay. Could you see my slide? Could you see my slides?
No.
No, actually, we see you. Just a moment. We saw the slide, but not now.
Could you see?
Not now.
No.
Could you see the slide?
No. Yes.
Yes.
Okay.
Yes.
Okay.
Just now. Just now.
Okay. Thank you, everybody, for your patience. I'm Giuseppe Musolino, and in this first presentation, I would like to introduce a research project that is carried out at Università Mediterranea di Reggio Calabria, financed by the Italian ministry in the behalf of Next Generation EU funds. The presentation is co-authored by Paola Panuccio, Corrado Rindone, Francesco Russo, and Antonino Vitetta, and mio, of course, which are the research group that are working in this project from the University of Reggio Calabria. And there is another research unit from University of Messina, which should present another part of the work inside this project by Orlando Belcore. The name of the project is National and Local Factor Affecting Ship Time in Container Ports. And the analysis concern the estimation of ship time in container ports in relation to some attributes related to ports and to the country that hosts the ports. So the analysis is conducted at two levels. If we go back to a well-established classification, the focus is on the third generation port, what is called container port. That are ports which have a strong traffic, container traffic, and are able to increase the value added connected to the movement of transshipment. So they are able to change, to move from a center of cost to a generator of value added. And then from this consideration, we know that there are different elements that influence the performance of a port, which is geographical position, function in the global supply chain, the level of administration and infrastructure dotation, and the digital dotation. And we can try the goal of the project is to find a synthetic indicator, which is the port ship time, that is able to quantify, to measure the capacity of a port, of a country system to compete in international trade challenges. Okay, this is the working areas of the project, the research project. There is a country level and a port level. Inside the port level, we have the seaside. On the seaside, the analysis of maritime services and the estimation of port ship time. And on the land side, there are some other working areas connected to path choice of vehicles to reach the port, and some other elements connected to the land use, to the hinterland of port, in order to allow the settlement of activities able to increase the value added of the port. So this is the outline of the presentation. I give you some elements, some synthetic elements in the time I have. I skip the literature review just to say that we are in the behalf of transportation system models, and in particular inside the component of supply. And we focus on the port node, which can be modelized by synchronic and diachronic models. But this is just a reference, the reference area where we are working on. The model specification, we developed several models, both at country and at port level, and the structure of the model, the general model, is the one you can see in this slide. We obtain as dependent variable port ship time that is influenced by different port attributes belonging to different categories. Just the notation with alpha, we indicated the parameters estimated at the country level, and with the delta, the parameter of calibrated at port level, but the structure of the model is the same. Just to show you some result about the model the process of calibration at the country level and at the port level. We worked with at the country level, we are working with different databases, open databases, UNCTAD, STAT, World Bank, Global Economy, and the reference working year is 2019. And we built our own database with considering different class of attributes. Attributes related to ships, to port infrastructure, to service, to ICT dotation, and to the economy, of the country. Just to remember that these data are at the country level, or aggregated at the country level, as given by the available databases. And these are some attributes related to the class I told you about. Just one example, some example of parameter calibration. I will talk in more details about this in the next presentation. For example, in this model, we considered a reference threshold of port ship time and two independent variables, which is the maximum capacity of ships and which is related to the infrastructural dotation of the country, the port system of the country, and the ICT technology index, which are two reference attributes together with the third attributes, which is the number of ship calls, which is an attribute according to us that refer to the organization of the port system of a country. We will talk later in the next presentation about these three attributes, where detailed analysis have been conducted. Concerning the port level, a similar operation, data gathering and data structuring has been performed, starting from AES data obtained by open source platforms like Marine Traffic, Vessel Finder, and Ship Job Marine, related to some ports, Euro-Mediterranean ports, Mediterranean and belonging to the Northern Range, and also in this case we built a database related to different class of attributes: ships, port itself, geographical area, and the structure of the services. For example, here there is as first exercise, two similar ports have been compared, which are the container ports of Gioia Tauro and Piraeus, which lie in the Mediterranean area, which are close, working in the same area of Mediterranean. So the results that you see is focused on these two ports. And for example, here we can see the results, some statistics about the time of ship in port, and the one attribute, which is the maximum ship capacity. And also here you can see some first results of the calibration at port level. And just a few comments. You can see that, for example, the reference value of the reference threshold of time of ship for the two ports is between 32 and 35 hours. And there is another parameters, minus 2.37, that set the difference between Pireo and Gioia Tauro. Is a dummy attribute that set the difference between the two ports in this model. And in another specification, for example, we introduced the capacity as a two-step capacity value, minus 500 TEUs, and the capacity for ships greater than 500. And we can see that ships, as expected, with as expected, we don't know. We need to analyze better this data. These results, ships that have a capacity greater than 5,000 TEU influence the dependent variable. And then a last model that I would like to show you is connected to the structure of the services. We introduced an attribute called the chain that indicates the fact that the services operated by the ships as an hub port or a feeder ports as previous of next connection. related to different areas. For example, we can see that services that operate have previous and next port belong to Mediterranean as determined at higher port ship time. This is just some example about the analysis we are working on, and then we have some first conclusion. We can say that at the country level, we can identify three attributes that refer to different situation. For example, the maximum ship capacity is a proxy of the infrastructural dotation of a country in terms of container ports, and of course an higher value determine a reduction of ship time. Then there is an attribute of ICT dotation. As the country is higher, has an higher level of ICT dotation, this influence ship time in terms of a reduction. And then the other attributes I talked about is concerned the port calls, also that is a proxy of the efficiency of the organization of ports. Some other consideration that are under analysis at the port level, we analyzed the effects of attribute related to ship capacity, to different geographical macro area, and to the structure of maritime services in terms of previous and next port touched by each ship consider, and I think I can end my presentation here. This first presentation. Are there any question about this presentation? If there are,
no.
Please, Elena, have you?
No, all clear.
Okay.
Compliments for your research. Very interesting.
Thank you. So I go to the other one. Because it's strictly connected, and then I give the floor to Elena. I do not see Orlando yet. I go to the second presentation that is shorter than this one, because I said many things. Dunque, un po', ok. Could you see my slide?
Yes, we see.
Yes.
Okay. Thank you.
You understand.
Thank you. This is another.
You can take full screen.
Sorry.
You can take full screen.
You can see the full screen.
No, it's okay. Go.
Also, the advancing of the slide, you can see.
No,
it's the first one.
first.
This is the problem. I go with other. With this, you can see or now advancing.
Yes.
Yes.
Now see.
Okay.
Now the third one.
Okay, the first one. This is a second presentation that deals with some further analysis conducted at the country level. You saw in the previous slide the different level of analysis at country and port level, and we selected in this part of the work, we selected some models that relate to the three main attributes that I described to you. And we make some further analysis that I will show in this presentation. I skip the introduction because there are similar parts that I talked before. The model is the one, and I like to show you this result, this further result. Okay. We focused on these three main attributes that are, according to us, proxy of some elements related to the country, the port system of the country, and we made some deeper analysis. In particular, here you can see the scatter plots between the average ship time in port and each of the three attributes: maximum capacity, number of ship calls, and ICT technology index. There is always a decreasing trend that is more evident in the ship calls scattergram, as showed as the value of calibrated attributes are in line with these trends. As you can see, this is a selection of models that were presented in the slide before, and we can see that if we see at these three parameters, for example, the maximum capacity of ship has negative parameters. Okay, the ICT technology index has negative parameters, and in model 2, where appear the number of ship calls, also it has negative parameters. And these parameters, these parameters are in line with the observation, and we performed different exercises. We applied some indicators. One indicator is the substitution rate, which is the ratio S, as you can see in this equation on the right, between a couple of parameters. For example, here we calculated the substitution rate again from the two parameters: maximum capacity of ship and ICT technology index. And we can see that this ratio, against alpha ICT technology index and alpha maximum capacity of ship, this one, we can see that this value is among 7.5, 6.9. And what show these values? That, for example, if in a country the level of the ICT technology index increase of 10%, so the country invests funds to increase the ICT dotation, the whole ICT dotation, this determines an impact on ship time reduction equal to an impact increase the maximum, the infrastructure dotation of ports of 740 TU, cioè increase the dotation of ports, the infrastructure dotation, in order to host ships, greater ships. So this is the meaning of this substitution rate. And also we can also calculate the substitution rate against between the ICT technology index here and the other attributes that is the number of ship calls. That is, as I said, a measure of organization of port system inside the country. Again, if we imagine investments in country that allow to increase the ICT technological index of 10%, this is equivalent to this has an impact on port ship time equivalent to the investment necessary to increment the number of ship calls inside the ports of 460. Cioè there are some investments in the efficiency of ports are needed to increase to obtain the same reduction in port ship time, again according to this model, of course. I don't go in the other inside the other indicators, KPIs that because I have no time. For example, direct elasticity is another KPI that we are applying, and then this is another KPI that relate to the comparison between observed and estimated ship port time that allow to validate the model. I go to the discussion and the conclusion. Again, saying again that these first results seems to allow us to associate these three main attributes that we are considering to different elements of the ports. The maximum capacity of ship could be associated to infrastructure dotation of a country in terms of container ports. The ICT technology index could be associated to the digital elements, to the level of the digitalization of the country system, and then to the ports in very large meaning. And the number of ship calls is a measure of, is a proxy of the efficiency of port organization inside a country. This, I repeat, are data that are aggregated at the country level. There are other elements that I don't say, but if there are some questions, we can discuss. Thank you. Thank you. Are there any question about this second part?
No.
Okay.
Fine, no.
Okay, I see now Elena and Orlando. Please, Elena,
Yes.
the floor is yours.
Okay, thank you. I'm sorry for the delay, but I had not considered a different time. Okay. Can you see my presentation?
Yes.
And now the second?
No.
No.
Not yet.
Now?
No.
No.
I think that is better that you don't give.
And
now,
okay.
now yes,
Okay,
yes, yes.
perfect. Okay.
No, without full screen. Okay, please.
Yes.
No.
Okay, perfect.
Please.
Yes.
You can start.
Okay, this research, the name is Enhancing Port Accessibility, Challenge, Measure and Sustainability in Terminal Design. I am Elena Cocuzza by University of Catania, and the other authors are Matteo Ignaccolo, also by University of Catania, and the director of the Department of Civil Engineering and Architecture, and by Cristiano Marinacci and Stefano Ricci by University La Sapienza of Rome, and Ellen Tverdi and Maja Stojakovic by University of Ljubljana, the Department of Maritime Studies in Portorosso. Just a moment. Okay. The ports represent an land-sea interface and a maritime land transport junction point. They are fundamental links to the global logistic chain. Thus, attention must be paid to a complex system, also made of retroports, interports, and also intermodal logistic platform, because the port-city interaction and between the decision-making actors involved in them are multiple. In fact, maritime transport and port operation generate externality on the reference context in a direct and indirect way, above all for an environmental point of view. In particular, in the urban ports, these criticalities are valued. In fact, the port system is a complex system, and there are many interactions between these two systems and between the stakeholders. On the one hand, the presence of ship at the port generates phenomena of environmental pollution, and the other hand, logistic activity also exert further environmental pressure, especially in the connection between the port and the urban areas. The sustainable management of these areas can help reduce the environmental impact of vehicular traffic by promoting the adoption of a more efficient and sustainable mobility solution. We can see the different main criticalities in this area. The aim of this paper is study critically the challenge and the measure related to accessibility, analyzing specific dimensions both for people and for goods, because the port accessibility is a crucial element in promoting sustainable development for the port city area. This research, as a part of the research project, the Master Design of Maritime Sustainable Terminals. The principal investigator of the project is Stefano Ricci by University of Sapienza, and the other partners are University of Catania and the University of Ljubljana. Also, Vincenzo Turrisi and Antonio Barbagallo, that are present now in this session, are involved in this project. The main objective of the project are to develop sustainable terminal design methodologies that integrate traffic dimensional and equipment parameters with life cycle-based sustainable criteria. Okay, now we can see the two dimensions of port accessibility, because accessibility in the port are for people, not also for the port operator, but also for the citizen and tourist. And the other hand, the accessibility for goods that require efficient multimodal transport network. The methodological approach of the paper was divided into 3 phases. Analysis of the main challenge in order to understand the role of accessibility in port terminals, the identification of barriers to sustainable mobility, and at the end, the definition of accessibility criteria according to the different stakeholders involved in the port city areas. We can see a brief literature review about the port accessibility. In particular, we can see in this slide the freight accessibility. The port distribution model by Sibiero, port hub, gateway ports, and feeder. And now we can see the different level of accessibility. According to Kallinen, the nodal accessibility that is based on the capacity of ship operating on the global network. By the gateway port and the concept of port regionalization, in particular for the port gateway, and in Italy we have 2 gateway, the Ligurian system and also the Nord Adriatic multi-port gateway system, where is also the Koper port, and the local interland network for the feeder port. We can see the example of Valencia that have a very good connection to the hinterland. Port city, the impact of port and urban development have led Port City to focus on exploring a more sustainable development scenario. Now, port spaces have acquired significant transformative potential because often are the unique opportunity to redevelop highly degraded or marginal areas. We can see some examples very famous in the world, like Alicante, Marsiglia, and Santander, that was imprinted urban redevelopment. But now the port area have a new attractiveness for passenger, tourists, and potential users such as citizens, because now in the port area we can see a new activity. For example, reception, transit, commercial, recreational, tourism, culture, and also urban spaces. Instead, about the not motorized accessibility for people, we can see we have a level, a local type of mobility. In particular, transit, about urban transport, and walking and cycle. Choose because the pedestrian mobility does not prioritize fast movement from a origin point to a destination, like, for example, the good. The choice of route depends not only on the destination, but also of the attractiveness of activity along the way, and also by the architectural or natural characteristic of the route. I'm sorry. Okay. We can see the stakeholder engagement process, because in the first phase we had identified and mapped the stakeholders in order to identify all stakeholders involved in the process, directly or indirectly. Then we should pose a questionnaire and collection the data, and at the end the synthesis data to highlight key challenge, proposal, and strategic orientation. This is this table reassume the typical stakeholders involved in port management and planner, divided in internal stakeholder or external. For example, institution, authorities, the public sector, or companies and operators in the private sector, and like external stakeholders, local communities like citizen, visitor, local communities, universities, and other, also transport users, and in the public sector, the Ministry of Infrastructure and Transport, regions, local authority, and other actors. The results of the research are divided into 3 tables dealing with the role of accessibility in port terminals. This is the table 1. The challenge for accessibility in port terminals, and the table 3 with the criteria for accessibility in port terminals. We can see the result of the role of accessibility in port terminals, and each stakeholder is possible to see that each stakeholders group has unique priorities. For example, maritime and logistic focus on improving operation by reducing ship waiting times, enhancing multimodal connection, and cutting congestion, which requires infrastructure upgrades and digital tools. The institutional and public entities face challenge in strategies, secure funding, and managing complex regulation, often leading to slow decision-making and investment delay. And social and end-user concern emphasize accessibility, equity, safety, and balancing efficiency with making port welcoming and safe, especially for vulnerable user. Improving port accessibility requires a coordinated effort that integrates efficiency, connectivity, and inclusivity. In the table 2, we can see the result of accessibility challenge. And maritime stakeholders emphasize modernizing port infrastructures by expanding berth, deepening waterways, and using intelligent planning system to reduce congestion. Logistics stakeholders stress improving connectivity with better road and rail links, intelligent traffic management, digitizes shipment tracking, and nearby logistical pathways for congestion. Instead, the institutional stakeholders call for streamlined regulatory processes and coordinated urban port development to avoid conflicts, address environmental issues, and engage the public. Social stakeholders advocate for inclusive, user-friendly ports with better public transport access, barrier-free terminals, that this aspect is very important, and services for vulnerable travelers. Overall, a comprehensive port accessibility plan involving infrastructure, technology, and inclusive design that is recommended alongside continuous stakeholder engagement, pilot project, and securing funding from regional and for Europe program. At the end, the result of accessibility of criteria, we can see that improving port accessibility means addressing the real need of all users. For the maritime stakeholders, it is important to require port equipment from modern, larger ship with expanded berth and upgrade terminal, reduce congestion, shore power to cut emission. In fact, the cold iron is very important, and digital tools to coordinate schedule in real time. That we can reassume this in the concept of a smart port. Operational logistics stakeholders focus on speed and efficiency through smart gate system, buffer zone for truck, flexible terminal design, charging station for electric vehicles, and real-time tracking to ensure smooth, transparent, good movements. For public authorities, it's important to support cleaner port operation with shore power, streamlined custom via digital pre-arrival system, improved coordination through port community system, and alignment of port growth with urban planning. And at the end, for social and user stakeholders, is important to have accessibility, welcoming passenger terminal with barrier-free pathways. Clear signage is easy public transport access and real-time travel information. In conclusion, we can see that port terminal development goes behind infrastructure, but require balancing economic, environmental, social, and technology aspect. The stakeholders identify barriers like infrastructure limits, congestion, fragmented policy, and lack of inclusive design. It's recommended to include modernizing infrastructure, digitizing logistics, enhancing public transport, integrating clean energy, and adopting smart technology for AEOI to optimize operation, reduce congestion, and improve sustainability. And the sustainable terminal design must serve all users, equitable and efficiently, requiring continuous stakeholders collaboration, clear policies, innovation focus, and on people and about the environment. In addition, it's very important to improve last mile solution and urban connectivity in order to reduce the emission. And the digitalization of the port logistic operation is very important. Based on the master project case study, the findings support future research and improved port planning aligned with sustainability, social equity, and climate mitigation goal.
Okay,
I have finished.
Thank you for your presentation, Elena. There is one time for one question, if there is any. We have just one short question. Thank you for your wide description of the level of accessibility of different scales.
Thank you.
I wonder if you have some identify some KPIs for calculation of accessibility in the future, and then at one of the different levels, and if you identified any measure to increase accessibility in one of the ports that you have examined.
Yes, during the project we have examined some case studies. For example, the ports of Catania and Augusta, the port of Koper, the port of Venice, and in the future we will measure with some methodology, in particular about the freight accessibility, because in the past we analyzed the accessibility for people by walking and cycle accessibility. Using GIS and measure like the utility of the pedestrian route and level of services. Now the next step of the research will measure the accessibility for freight.
Okay, thank you. If there are no any questions, I can invite Orlando Beltore to start his presentation. He's the last one of the session.
Okay. Good morning. Everyone can see the screen?
Yes.
Okay, perfect. As we mentioned before, we are experiencing some shutdown for the electricity. So I start, if something happen, I try to skip in another position and use my mobile phone to
Orlando, during this session, everything happened.
Okay, perfect. Because I was home to take my PC, and now I came back to the.
Okay, please go ahead.
On behalf of the group of transportation of the University of Messina, that is composed by Professor Di Gangi, me, and of course Antonio Polimeni, that is here. I'm going to introduce our paper that is like an experimental case study, like a toy model that concerns on how containers move. So it falls in the domain of the deep sea shipping and freight distribution on large scale. What we are going to highlight in this case is like how to organize the movement from this freight, considering the units of the container as the main kernel of our assumption. So we will focus on cost of transportation and delay that are related to this phenomenon. Of course, why we decided to focus on this, because our motivation is based on the importance that sea shipping has on the complex trade in the worldwide, and of course we are experiencing in the last 5 years at least how our networks can be fragile. It depends on, for example, wars condition, also of course also the COVID that we experienced 5 years ago. So the time that elapsed for the expedition, or of course also the possibility of the physical infrastructure to deal with these triggers is important to be studied. Also, it's important to focus on how to recover on it. So in this work, we are starting to introduce this and maybe hoping for future developments on it. What we are going to see, we approach the problem dividing it into 3 steps. So starting from the network is definition, like a graph. Then we pass to start the distance and how to reach for the single container each port from its origin to its final destination. And if when it's necessary, also considering that is necessary to make some transshipments. So, of course, our key aspects can be resumed in the interaction between lines and physical infrastructure. And we also operated some statistical measure concerning mainly on coefficient of variation of times for the delivery. How is conceived cost in our model? We thought to consider the single container in its process like a single person who had to take the bus. So costs are considered in under this assumption. So how is modeled the network? We start from shipping lines and ports and their characteristics. Then we start after the graph construction to work on the network associating costs, and in the next slide I show you. And then we pass to the mesoscopic simulation where the unit of the mesoscopic model is the container itself. But in which way, considering the classical event that happens in in a container port, also that can be resumed by ship arrival, waiting at the anchor, then handling operational dock, and then following departure from the area. So by this way, we start with port position and ship line frequency, and we showcase two different lines. And so by this, we constructed the supply model, the graph, considering nodes as port and shipping lines as a link between ports. And of course, this also implies that necessary to focus on this link and their costs. And costs are divided by considering the time elapsing between 2 ports, like the time necessary to reach different position, the loading time for the arcs, and also the unloading operation at the container port. The supply network is based on these two cases, that is the Amerigo line and the Crossmed, that are specific frequency and a specific number of ship feed size. All these data were broadcasted from online, and we also consider the duration in days of the long route, and the number of port call, the port that are visited by each one of the vessel. So we consider from origin to destination for each container, considering port and interaction. So each line connect different ports, and in this area, generically we consider a loading, disembarkment, or loading operation. By this is considered the cost, like the average waiting time between two different vessels that visit the port for the lines, and the loading times that here are presented like the purple line, and the handling time that is associated with the operation on disembarkment, that are the one that are delivered in black. Of course, the navigation time we have just evaluated, considering for this toy model, just considering the starting time and the departure time from the scheduling, and no weather condition or other criticalities are at the moment considered in the model. Maybe in the future we also will try to make a rescheduling or retouring for this kind of inconvenience. So by this we have the graph, the cost of the cost associated with ARC, and we try to simulate the process, considering the shortest path that led our container to arrive to its final destination. As I mentioned before, the discrete event simulation for the port is based on these 4 times that can be also better explained by this representation. So generically we have the ship arrival, the anchoring time, when the berth is available, we can process to go to the berthing operation. The handling happens, and some of these are discarded on the layout of the port, and then the vessel leave. These or considering all the moments that passed that are into the discrete model simulation, we have the vessel turnaround time that each vessels have to experience within the port area, and itself also the container that is handled during this operation. So by this, the single packet experience some operation and some times that can be considered as the waiting time, the waiting time at the container port, of course, the travel time is the time for the linking each port, and when necessary, because sometimes some lines, some couple of OD also require the transshipment operation, we also consider it into the time definition of the total process. So the case study is based on this simulation that concerns a total group of 17 ports that are the same that we showed before, and our simulation covered a minimum period of 60 days. Of course, if more time was necessary to complete all the operation, the simulation contained this. And we experienced to study different range of distance between OD pairs. And as I said before, also in our OD pairs, at least about like the 40% also required the simulation for transshipment or operation. So considering this cost into the complexity time of the container travel. So we decide to observe the total time, the travel time, the transshipment time, and the waiting time, and we observed how it varies between different relation and distance. So we can also experience how stable are these in our simulation, of course, this kind of process. And here we in our table is presented the number of OD pairs that falls into a specific range of variation for both total time, how travel times can affect this, the same for the waiting time with this range, and the transshipment related only to this kind of lines that handling operation that require it. So if we want to resume, our study presents a simulation framework for reconstruct the movements for containers units, so falls into the domain of the atomization of the total supply chain, the logistical distance. We try to make a parallelism between movements of other kind of public transportation and this is specific case study by identifying the network, providing a descriptive and simulation, also approaching it by observing the resuming characteristic for a mean time, travel time, or the other variables for the container. As I mentioned before, two different lines were covered, and in the near future we would like to integrate this like toy model with real-time data, or also maybe add on consideration on other statisticals to test the stability of our model, but also to try to make a parallelism between the economic growth of a region and the stability of the transshipment, the vessel routes. And of course, maybe also introducing some unexpected behaviors or just some lacks to be able to modify the routing and maybe offer new solutions that at the moment are not considered. So thank you so much for your attention.
Okay, thank you, Orlando. Are there any question about from the audience? If there are no questions from the audience, I have one question. It seems if I well understood, could you eliminate the slide, Orlando? Okay, thank you. It seems from to me that you consider the cost function on the links and on the nodes is based on travel time. Is based on travel time.
Yes, is like we consider the time necessary to for the container to reach one position to the other, one port to the other. It's considered by travel time. It's a part of the cost. The other two aspects that are concerning are the waiting time. So that the time that the container wait before entering into is all.
It's travel temporal components. The cost function is composed by temporal costs.
Yeah.
Okay.
Three different: waiting time, travel time, and transshipment time when necessary.
Okay, understand. No. The question is if you plan also to introduce other cost component like monetary cost, like cost connected to the ships, for example, to the ships like capital operating cost of the ships, capital cost, and fuel cost that have also impact on the determination of the costs of the services.
Yes, of course. This is like because I mentioned in the end that we also would like to add some specific kind of variables that are connected with economic growth or a region, or for example, just the kind of freight that is delivered by these containers, also comparing the difference between vectors, but it's like in progress.
Okay, okay. Are there other questions? Okay, thank you. If before closing, I ask to Professor Russo if to give us some general comment about the session and the work done. Thank you, Professor.
Thanks, Professor Musolino. I just two considerations that can be interesting. The first one is that historically in Italy, the study of port in the different consideration, the maritime transport and so on, is developed by economy department. We remember that the big work and very interesting paper produced in Genoa, in Trieste, and in other faculty, but mainly in economic department. The first time in this section, I saw that all the presentation derived from engineering faculty department with different components, but from architectural to electrical to industrial to management and so on, but with a specific character derived from engineering. And then, how do you say, with a very important link with the territory, with the civil aspect, and not only in terms of economic aspect, as is the classical one. The second consideration, and finish in the time that we have in the session, I think that is interesting that in the different presentation that we have, we consider in the different presentation different aspect and different generation of port as classified by UNCTAD, because we have specification for the generation of port city, that is the first generation identified by UNCTAD, and in the first two presentation by University of Catania with Rome and Ljubljana, we have this very important consideration for the relation between port and city. In the other presentation, there is the third generation, the container port, as in Reggio Calabria, in Messina, and in other universities. Then I think that the first consideration, the engineering now is very important to study port. Second, the engineering gives us the possibility to approach the different typology of port and to go in deep in the different attributes and functions that you have in each port, from accessibility to time or route and so on. The third is very easy. The consideration is interesting that all this university, that all this department is in the south of Italy. And then I think that can be a very wish for the south of Italy to develop an industrial port, because it is incredible that the south of Italy is inside the Mediterranean Sea, but don't use this great resource. Thanks, and see you next year.
Okay, thank you, Professor, for your interesting consideration that point out that there is a wide corpus of research carried out by transportation engineers in this field, and also from the south of Italy, southern universities. As we can see from this presentation, that belongs to different projects. There are different research projects that connected in any way different universities. So there is also a network created by these research opportunities. I am very satisfied about this session. and I think we can close this session, and best regards, and see you in the next conference. Goodbye, and also in other occasion where we can meet each other in these universities. Thank you.
Thank you.
Bye.
Bye.
Buon pomeriggio.
Bye.
Bye.
Ciao a tutti.
Arrivederci.